let's start the physics stuff. Jackson, today is mostly going to be a terminology lesson, but we are going to start with our first concept and our first, we'll call it an equation. It's one that you kind of already know, but then I'm going to take it and run with it and see what we can do with it. First of all, in physics, every measured quantity is either a vector or a scalar. You may have heard those terms before. In fact, somebody here in this block a couple of days ago asked me what a vector was. So anytime I introduce a new concept to you, one of the first things you'll need to memorize is whether it's a scalar or a vector, but you won't need to do flashcards and somehow repeat it over and over. You'll just memorize it, Maya, naturally, because I'll just flog it to death so much. What's a scalar? A scalar is a quantity that has magnitude, and magnitude is the fancy word for size only. And then it says, for example, Carson, I'll fill those in a second, but I want to explain what a vector is so you can contrast it. A vector has both magnitude, size, and direction. So let me give you an example of a scalar. Mass is a scalar. That object has a mass of 8 kilograms. Makes sense? That object has a mass of 8 kilograms north. Does that even make sense? Mass does not possess direction. It possesses size, magnitude. Volume is a scalar. 3 liters, not 3 liters 40 degrees west of south. Doesn't make any sense. Mass we'll be looking at a lot this year. Volume, no. But another scalar we'll be looking at this year like crazy is time. Time has no direction and it's always positive. If you're ever solving for time and you got a negative answer on your calculator, Jada, you've messed up. But I watched one time they went backwards. No. No, 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 no. Time cannot be negative. Some examples of vectors. Velocity is a vector. Force is a vector. It makes a difference which way you push something. There are many, many others. In fact, we're going to make a little chart here, and we're going to compare a couple of objects that are available both in scalar form and in vector form. Brandon, the first one I want to talk about is speed and velocity. An example of a speed, 30 kilometers per hour. That's a scalar. An example of a velocity, 30 kilometers per hour north. That tells you not just how fast, but which way. Mr. Dewick, what, Lauren? Can you come up with an easy way for me to remember that speed is a scalar and that velocity is a vector? Mr. Dewick, if you were a good teacher, you'd have an easy way for me to remember that speed is a scalar and velocity is a vector. Lauren, you're right. I can't think of anything. I'm a terrible teacher. You're on your own, and you'll just have to come up with something yourself. God, I hope you all picked up on the hint there. Time is a scalar. I already said that. One of the ones that we're going to be looking at an awful lot this unit, Lean, is acceleration. Acceleration, I'm going to abbreviate Excel. That's a vector. If you're accelerating forwards, positive, you're speeding up. If you're accelerating backwards, you're slowing down. Or you're speeding up going backwards. Depends how you were traveling to begin with. The tricky one, and this one I don't have a dumb, stupid way. If you do come up with a dumb, stupid way to keep these two straight, tell me and I'll use it for the rest of my teaching and I'll give you credit. Distance is a scalar. Displacement is a vector. Distance, 12 meters. Displacement, negative 12 meters. What would negative 12 meters mean? You ended up 12 meters behind from where you started. Now, in Physics 12, those of you that sign up for that, we will be getting into vectors way, way heavier. We'll be doing two-dimensional physics. In Physics 11, it's going to be one-dimensional physics. For vectors, we're going to keep our directions pretty simple. If an object is a vector and it's moving forward, we'll call that positive. If it's moving backwards, we'll call that negative. If it's moving up, we'll call it positive. If it's moving down, we'll call it, and that's as high-tech as we'll be. Okay? There will be sometimes later on this year, though, where we'll say, look, instead of always having up be positive and down be negative and forward be positive and backward be negative, we'll start to let positive be whatever makes the math easier. And you'll see in a while there will be situations where, oh, let's let down be positive. It'll make the math way easier. We'll do that. But we're going to keep it pretty basic that way. We'll decide one way is positive and one way is negative, and we'll only do that if we clearly see there are two different directions in the question. Some symbology. To show an object is a vector, so the abbreviation for velocity with a vector, textbooks will write it in a bold font. The abbreviation for velocity is a lowercase v. It's really tough to handwrite in a bold font, so we don't use bold font in our handwriting. Instead, look up. The symbol for a vector, we draw an arrow above it. Although, Ashton, we've gotten so lazy over the years, we actually only put one of the points of the arrow. We don't even fill in the bottom one. That's velocity. Everybody look up. That's speed. That is the velocity with no direction, speed. Vector, scalar. This is one of the only tricky ones, and that's displacement. That's distance. I am not going to take marks off if you have sloppy notation, but I will be, especially where there's multiple directions involved, nitpicky in our notes to help us realize we better pay attention. So if you meant to write displacement and you go displacement equals 3 meters north, and that's the correct answer, I'll give you full marks. I might say when I'm marking it in red, hey, by the way, you forgot the vector symbol, but I won't dock you there. Okay? Oh, I wanted those back. Where's my vector? There's my vector. Let's talk about the difference between distance and displacement. Which one is a scalar? Distance. And unfortunately, they both start with D. In fact, they both start with D. Son of a gun, they both start with D-I-S. I haven't come up with a dumb way to remember that distance is a scalar and displacement is a vector. The problem is scalar is S-C-A-L-A-R, 6 letters. Vector is V-E-C-T-O-R, 6 letters. I even thought of that one, and I thought maybe the shorter one would go with the shorter letter. Nope.
No.
So you're saying because it's shorter, you're not writing as much?
No.
Because if it's good, I'll use it.
Yeah, I'm using it.
Okay. If it works for you, great. Yes?
The vector has a t in distance as well, so they consider the opposites. Because if you look, scalar.
See, but now you're having to realize they're opposites. Give me 1 second. So, oh, yes?
I only have one stupid way that might help me remember.
Okay.
Versus displacement is to of scalings and decrements?
See, first of all, by the end of the year, here's what might work. Here's what I know because I've done the whole physics course. Time is a scalar. See the T? P is the abbreviation for momentum, which is a vector, and I've happened to remember. So that's my way of doing it, but that's because I know what time and momentum are, and we'll get there by June, but that's not going to help you now. Right now, all I'm going to say is I'm going to just keep repeating it a bunch of times, and hopefully it'll just stick through sheer repetition. What is distance? Distance is how far an object has traveled. We are going to abbreviate all the time. So anytime I introduce a new concept, like I am now, I'm going to give you its abbreviation, scalar or vector, and preferred units. So what's the abbreviation for distance? Well, if you're in Britain, Isaac Newton, because he wrote in Latin, he liked to use the letter S as his abbreviation for distance. The problem is nobody in North America uses that, and my S's look like 5s, so you can cross that out. If you take university physics, they'll use the letter X as their abbreviation for distance because they want it to be like you're on a graph. When you're moving back and forth on a graph, horizontally, what variable do you use for left and right, Cody? X. What about for up and down? And so I understand why they do that, because then it's an easy way to hint up, Y, sideways, X. Not a fan. I'm going to keep it stupid and use D for distance. Why? D for distance. Yeah. Units, meters. Which means if we have a distance that isn't in meters, if we see that, a little ding, ding, ding will go off in our brain and we'll think we might need to convert that. And I'll do a few conversions for a couple of days because normally I'm doing this as part of the review for the quest, but eventually you'll start to notice, he's given us everything in the good units. Scalar or vector, distance is a scalar. You can write out the word scalar, or if you're like me, circle the correct one, and I think you'll figure it out. I'm lazy but organized. Displacement is an object's change in position. Symbol, well, in Britain, they'll use S with a vector sign over it. We're not going to use that. Many textbooks will use an X with a vector sign. We're not, you know what? I'm going to use D with a vector sign over it. That's a terrible vector sign, Mr. Dewick. Do a little neater. Units, also meters. But this is a vector. Basically, displacement only cares about where an object has started and where it ended. It doesn't care about the path in between. The easiest way I can explain that is to go for a walk. Sorry, those of you at home, this doesn't work. I'm going to pause the video. Other things, when an object starts moving, it's useful to be able to describe its location. And so one method we'll use is we'll imagine that a meter stick is placed next to the object like a number line going in all directions. We'll have some kind of a 0 point, a starting point. And then if we're moving to the right, we'll call that positive. If we're moving to the left, we'll call that negative. So here I have a bug walking along a number line. It starts at location A. It walks to B. Everybody draw an arrow pointing from A to B like that, just so we can visualize and you get to draw a little picture. You'll learn this year I have two acronyms that I use very frequently. One is DFIC. You'll find out what that is in a couple of days. But another one I use all the time is DULP. And DULP stands for draw a little picture. You'll often hear me say, when you ask me a question, did you DFIC? Did you DULP? No, do that first. I'll come back and help you. So when in doubt, DULP. Draw a little picture. So here's our little picture. Then what does it say? Maya, it says it starts at A, walks to B. Maya, can you continue reading from the word and right there? Then?
And then turns around and walks to C.
Boom. Got the picture? What distance did the bug walk? How many meters? Distance. Distance is never going to be negative because that would imply some direction. Distance has no direction, much like your future. Distance has no direction. Is it? 1, 2, 3, 4 steps this way. How many steps this way? Not 6. How many steps this way? Okay. The distance was 4 steps forwards, 10 steps backwards, yes? For a total of? And distance does not care about direction. The running joke I always say, it has no direction, much like your future, right? That's funny, Mr. Newick. There you go. Laughing at my jokes improves your grade. Okay, what about its change in position, its displacement? So the displacement, where did it start? 0. Where did it end up? -6. Its displacement is, and you could write this one of 2 ways. Look up, I'll show you the long way. 6 meters left. What's a better way to show left? Write that. Here's what I would mark wrong. If you wrote -6 meters left, I would argue that negative left is right. Right? Right? Right. Negative left is right. Right? Right? Right. So don't do a double, don't not do double negatives. They're confusing. Don't. I've lost you. Turn the page or next page over. So here's a little thought puzzle. You see path 1, path 2, and path 3. In only one of those paths, the distance and the displacement have the same magnitude. In which path do the displacement and the distance have the same magnitude? Path 1, path 2, or path 3? Loud and proud. Path 2. Now this question actually asked along which path would your distance be different from your displacement. So we'll answer path 1 and path 3 because path 2 is the only one where it's the same. But for all of these, the displacement would just be that straight line path. The distance will be whatever. Is that okay for the difference? Okay. Sometimes we can use arrows. We'll eventually start doing this much more mathematically, but sometimes we can use arrows to represent a displacement. So a bike moving on along a number line from a position of 4 meters to a position of -3 meters, the arrow's pointing to the left. But again, we're going to abbreviate. The word that we'll use for our starting point, Carson, is which word here? It starts with letter I. The word that we're going to use for our starting point is which word here? It starts with letter I. I'm going to abbreviate that typically with a lowercase I. And because I have people in the back row, so that you can tell it's not a 1, I'll always put a little curly, like I'll make it look like an italicized I, so it's obvious I'm not putting a 1, I'm putting an I. What word are we using for our ending location, Carson? Starts with letter F? We're going to abbreviate that with an F. So already, if you look at your formula sheet on maybe the 3rd or 4th row, you'll see a bunch of things with subscripts, I's and F's. Those are initials and finals. And we'll be using that like crazy. Because why write out if we can abbreviate? Right? Right. But not negative left. Right? Okay. So I wrote here, we're going to use a variable, x or d, to symbolize an object's distance or displacement, and subscripts, initial or final, are our standards to show initial and final. So example 4 says, draw an arrow showing an object that moves from the -4 position to the +5 meter position. First thing I'm going to do is put a little dot right there. There's the -4 position. And I'm going to put a little I for initial. Takes 2 seconds, lazy but organized. Ashton, where am I ending up according to this question? Put a dot there. How will I label my final position? With a lowercase what? Good. And then I'll draw in the arrow. I'll do it in red so it stands out. You don't need to, but I'll try and make my notes colorful just so that if you're in the back, you can see. All right. What's this object's distance? And I'm going to go d equals, just to get used to the variable. What's this object's distance in meters?
9.
Yeah, what?
9.
Yeah? 9? 9, yeah? Yeah, 9. Units? Meters. What's this object's displacement? Also 9. If I really wanted to show that it was to the right, I wouldn't mark it wrong if you went positive 9, but in math, if you don't put anything there, do we understand it's positive? Then if you wrote 9 meters, I'd give you full cred here. You could add the word to the right, like right if you wanted to, but whatever. Let's get a little more challenging. Draw an arrow showing an object that moves from the 7 meter position to the negative 2 meter position. Okay. There's the 7. I'll put an initial there. There's the negative 2. I'll put a final there. I'll draw in my arrow. Sound effects sometimes help. Okay. Lauren, when you're done yawning, what's this object's distance? Yeah, no problem. You can count. I have no problem with that. 9, yeah? Yeah, 9, yeah. Is there a way you could have figured that out mathematically without counting? Where did we start? 7? Where did we end up? I think you could have gone 7 minus 2. If you just subtract the numbers, when you're subtracting, you're technically, mathematically always finding how far apart. I don't care how you get there. Now, obviously, Lauren, if instead of a 7, it was 3,924, and if instead of a negative 2, it was negative 4,319, I would not recommend your counting method. It's doable, but try and find something better. Okay, what's this object's displacement? I'll give you a hint. 9. See how I did that? Yep. Or you could say 9 meters left. Which one's shorter? Do that one. I won't mark it wrong, because saying it that way is fine, but... Okay, let's get a little trickier. Draw an arrow showing an object that moves from the 7 position to the negative 2 position, then to the 3 meter position. Okay. So it looks like my initial lean is still here, 7. And then lean, where does it say that I move to in the middle? Okay, I'll put a dot right there. I'll draw that arrow. Duick, thank you. Easy mistake to make. Thank you very much. Negative 2, Mr. Duick. I'm not going to label that with a final, because that's not where I ended up. In fact, lean, where did I move to afterwards? Okay, so 3 meters, there's my final. And I usually draw the second arrow just above so they don't overlap so I can see easier. Okay. All right, Schmarty peoples, what's the distance here? I'll give you a hint. It's not 9.
13.
Isn't it 14? Yeah, you're right. How did you get that? It's going to be 9 plus 5. Now, if you did that in your head, in the homework, go straight to the answer. In our notes, I'll always show a bit more work so that when you're studying later on, you know what the heck we did. So I'm going to go D equals 9 plus 5, just to say, that's what we did, 14 meters. But, in fact, I would say, don't show me that step in the homework. I'm going to guess most of you can just get there. Displacement. Negative 4. It doesn't care about the path that you took to get there. It says, where'd you start? 7. Where'd you end up? 3. How could you get that mathematically? So what we always say is displacement is your final location minus your initial location. 3 minus 7, negative 4. Okay? On your green sheet, the very, very first thing on your green sheet, Brandon, says what? Okay, what's that triangle? Now, by the way, I'm not going to make fun of you. I will in a month. We don't say triangle. What do we call, what's the nerd way to pronounce that in science? Yes? Okay, we call it a delta. So delta equals what? It's a synonym. So you actually, when you're reading it, you can either say delta or you can say change in. What's change in anything? Keep reading. Say it again. You're right. What's change in anything? That's exactly what I want you to repeat, not to make fun of you, but to one more time. What's change in anything? Look up. I told you way back when that displacement was an object's change in position. So one way to find displacement, change in, would be to go the final position minus the initial position. That works. Okay. No one does it that formally. Most kids just kind of figure it out, how far apart they are, and then they add the negative if it's left, or they add the positive if it's right. But for what it's worth, it works. Draw an arrow for an object that moves from the 4 position to the negative 3 position, and then back to the 4 position. I guess. Well, let's do the distance first. What's the distance? 14. What's the displacement? So what does 0 displacement mean? You ended up back where you started. Okay? Any racetrack, technically, if we're talking displacement, all of the race cars, if they reach the finish line, which is also the start line, they all have gone nowhere. If we're talking displacement. Does the number 0 have a direction? You don't need to make it negative or positive, because 0 sitting in the middle, it's technically neither. All right. One more. If you give your vacation in terms of displacement, yeah. Yeah. You're going to see we're about 80% of the time going to be talking about distance because it's a more interesting one, but there will be, when we start to look at dropping objects off cliffs, displacement is going to be very important when we look at free fall. Speaking of free fall, a ball is thrown straight up into the air. It rises a distance of 11 meters and falls back down, returning to its origin. What distance did it travel, preferably in your heads? How far did it travel? 22? 11 up, 11 down? But technically, what's its displacement exactly as a number? Yes. Okay. Does that help you kind of understand the difference between distance and displacement? That's really why I did that. Believe it or not, I'm not going to be asking you any questions like this on a test. This was purely to just help your brain figure out the difference between the two concepts. What we really want to talk about is how that relates to speed and velocity. Average speed. Average speed is symbolized with VAV. That's a bit of a fib. Can everybody look up for a second? Don't write this down. There is an abbrev for average. The abbrev for average is a horizontal line, no vector arrow. But when I type these and shrink them down, it's really difficult to tell the difference between that and that. And so I think what you'll notice on your formula sheet, correct me if I'm wrong, I think somewhere you'll see a VAV somewhere there in the first or second line, I hope somewhere maybe? Average. Oh, I added the G? Okay.
No, you wrote the full average.
I wrote the full average?
Yeah.
I didn't abbrev?
Multiple times.
That's never going to happen again. Anyways, it is your distance over delta t. Where, Brandon, what's delta and abbrev for? 2 words. Now you got your Q, okay, that's going to be your line. Call your agent, you've got a part. There's no small parts, there's only small actors. So this is your big break. As an equation, we would write it like this. VAV equals D over. Time is a bit of a strange one. Time is always a change in, because according to your green sheet, what's change in anything? What minus what? Okay? Whenever you're timing something, you have to start and stop a stopwatch, and the stopwatch is doing the final time minus the initial time for you. Because time is always a change in, we get really sloppy, Cody. We stop putting the delta in front of it. I think, did I on your formula sheet give you V average equals D over T somewhere? Okay. It's technically D over change in time, but it's just it's like in math, nobody writes 1x. You just write, it's understood. Okay. Units, we can figure that out. What are the units for distance? We told you this a few minutes ago. Meters, what are the units for time? So if you see meters per second, you know that that is a speed. And it is a scalar. If I was a good teacher, I'd have a dumb way for you to remember that speed is a scalar. Got nothing. Average velocity is displacement over delta t. Where once again, Brandon, delta is an abbreviation for which two words? Well, good, well done. By the way, you'll notice when I teach, if there's a key concept, I'll often just pick someone to kind of be the spokesperson for the class for that. You'll all get a chance. So call your agents. Got your parts. As an equation, how do I turn that from speed into velocity? How do I make that a vector? Vector symbol. How do I change D into displacement? Vector symbol. Time is a scalar, so it has no direction, much like your future. Anderson, what would the units be? What are the units for displacement? We told you a few minutes ago. Can you be more specific by the same thing? Yeah, it's also going to be meters per second. So if I see meters per second next to a number, I know it's a speed or a velocity. Usually it's going to be a velocity. From what you've seen of me so far, do I like memorizing stuff or do I prefer not to? Okay? You want to memorize units. It's worth memorizing what units go with what. And as someone who hates memorizing, if I tell you that something is worth memorizing, you know what that means, right? That means that it's really worth memorizing! I'm sorry, I was trying to hope you would sit up because I was going to go full bore. Sorry, Maya. What we're going to start to do, Cody, is we'll memorize what units go with what. And when we're analyzing physics problems, we'll actually just scan them for units and we'll know all the stuff that's there. We'll analyze it really quickly. We won't actually have to process much. So you won't need to do flashcards. If the day before the test you're shaky on the units, fine, do some flashcards. But generally, kids that do the homework, you just memorize them out of laziness, which is the only reason you should memorize something. And velocity is a vector. I haven't come up with a good way to remember that. You figured out my joke there, yes? Okay. A little worried about some of these people. I get it. If the bug strip mentioned in example 1 took 30 seconds, what's the bug's average speed? So average speed is going to be the distance over the time. How much time in this question? How do I know that's the time? What are the units next to it? So I never said the word time, but seconds is time. So there's going to be a 30 on the bottom. I saw somebody turn back to example 1 already. What was the bug's distance way back in example 1? Was it 14? He says, but he's not sure. Was it 14?
Yes.
Okay. I'm not going to be fussy. You do not need to put the units in your workings. You can. You have, Verizon, your final answer better have units. Hey, on your calculators, what do you get? Do you get 4 point and then the 6 repeats? Let's decide, when in doubt, final answer, 3 sig figs. Because technically, that 30 is 1 sig fig. Technically, I should say 0.5. That's so much rounding off and so way off from the answer, that creeps me out. So I'm going to go, the third sig fig is this second 6. Is that 6 going to stay a 6 or become a 7? 0.467. Why would I take a half mark off? Yeah? Thank you. What's the bug's average velocity? Well, it's going to look really similar in notation. And time, Lean, is still going to be 30. But Lean, can you go back to example 1? What was the displacement we said from example 1? Should be there some. In fact, I'm trying to remember. I think it was negative, wasn't it? Example 1, displacement. You got it. -6 or positive? Oh, okay. Yours was was it -6? Okay. So, by the way, what you should get in the habit of, I'm being serious, make your negatives larger so that you never miss them like that again, right? There's certain little errors we can fix that are preventable. For me, also look up, everybody. I will always draw T for time like that. I will never draw it like that, because what does that also look like? So I will always put a little curly, you'll tell that's a T, that's a plus sign. You don't have to, but I will try and make my writing as clear as possible. By the way, I think I'm doing this one in my head. You get -0.2, yes? Yep. If you wanted to go to 3 sig figs, I guess you could go 0.200. I'm not going to be that fussy, but just for practice we can. Units, meters per second. What does this tell me? It tells me on average the bug was traveling backwards. Right? That's what the negative means. Its speed, on average, was about just under a half meter per second. Fairly quick bug. But on average, since it ended up behind from where it started, on average, it was traveling backwards. Oh, it must have, because it ended up behind from where it started. -6. None of that is going to be on your test. This and remaining I would consider fair game for the next unit test. This is the physicsy stuff. If V average equals D over T, then what would be an equation for displacement and time? Everybody do me a favor, draw a line down the middle of the page. Now, I wrote V average equals D over T. I'm going to tidy it up just to do some algebra. Right here, write V equals D over T. Chuck the vector signs, chuck the average. We'll bring those in at the end, but we won't let them clutter up our works. Davin, how many variables does this equation have? How many equations does it actually contain? How many variables does this equation have? How many equations does it actually contain? The same number. 3. If an equation has 4 variables, do you know how many equations are contained in that single equation? 4. If an equation has 5 variables, do you know how many different equations are actually contained in that single equation? Everybody? 5. Would you like to memorize all of them? Or would you like to derive them? I'm going to teach you, starting today, how to derive equations from one base equation. And I'm going to push you to try and do this in your head. This will also domino over into your math. I was helping someone earlier today rewrite equations in slope-intercept form. And my heart was groaning because we were showing every step. And I was saying, boy, in 2 weeks, I'm expecting that kid to do it in their head without writing anything down. And I'd like to get all of you to that point. So this says, what would be an equation for displacement and for time? Here's my equation. I want to get the d by itself. What side of the equation is the d on? The left side or the right side? So, what side of the equation is the d on? The left side or the right side? The right? That means the left side just drops down like a domino. I always do that first. The side that the thing isn't going to change. What's on the same side as that d? What other letter? Is that t adding, subtracting, multiplying, or dividing? So, dividing by t on the right is the same as doing what on the left? Multiplying. Okay? So, tuck a little t right there. And then look up. Everybody look up, please. Everybody. I need everybody to look up. Okay? Watch. Don't write this down. That equals d. Look, do you mind, instead of putting the d on that side, we're used to having the thing by itself on the left. Can I just do that? That's our equation for distance if you know the speed and the time. That's also our equation for displacement if you know the average velocity and the time. I'm not going to memorize that. I might have given you that one on your formula sheet, but eventually I'm going to start only giving you one equation and expecting you to derive all the others from them. If I can get all of you there, and I usually can, trust me, it's a much better way to learn stuff. I've dropped your memorization down by about 80%, which I think is good. What else does it want me to get an equation for? Let's get the t by itself. Where is the t in this equation right here? On the, looking for a word that starts letter B. Blech. This one, where is the t? On the top? What side is the t on? Left side or right side? Left side's going to drop down like a domino. What's right next to the t, Lauren? What's the v doing to the t? Adding, subtracting, multiplying, or dividing? Because there's no things between it. So how would I move it over? Or multiplying by v on the right is the same as doing what with the v on the left? Think opposite operation. Yeah. And then everyone look up. That equals t, but instead of, do you mind, I'll put the t equals over here on the left because that's where we're used to seeing the thing by itself. You don't have to, but we're going to start to just develop that habit. And now I can bring back all the vector symbols. Also, displacement is average velocity. Displacement divided by average velocity will give you the time, and distance divided by average speed will give you the time. 3 equations in one. Which one of those did I give you on your formula sheet in that first row? I know I gave you this one, yes?
Yeah.
Sorry, the V ab equals displacement. I gave you that one, yes?
Yeah.
Did I give you the other ones?
The velocity is
You give us
initial and final.
That's the second line. Don't go to the second line. Just stay in the first line.
equals the average.
Oh, okay. I gave you this one.
Yeah.
Okay. With or without vector signs, I figure you can stick the vectors on or not, but okay. I'm going to stop doing that. You with me? I know I've been talking a lot. We're nearly done. Are we? Yeah, we are. So we'll butch through the lesson today. Tomorrow, the first 20 minutes or so, I'll turn that into a study session. Finish the quest. Your homework is going to be this for the long weekend, but we'll try and build some time in Friday, flex, or whatever. I'm sorry that assembly caught me off guard. I like example 7. A motorist, why would I say that? Okay. A motorist travels 350 kilometers during a 6-hour period. What is his average speed in, Nate, what does it want for the units for part A? No, what does it want for the units for part A? Just read it to me. Okay. My preferred units are meters per second, but these equations will work for any units. What do they want our units to be in, Nate? Say it again. What are the units for this right here? What are the units for this right here? You know what? We can just plug and chug this. So, what does it want us to find? Average speed. The equation that I gave you was average speed is distance over time. What's the distance in this question, Nate? How do you know? Kilometers. Not our preferred units, but that's okay. What's the time in this question, Nate? How do you know? Hours. This will give us an answer in, look at the units, kilometers on top, hours on the bottom. This will give us an answer in kilometers per hour. What do you get? This is the one most of you are familiar with, or you will be once you start driving. Yeah, Leon, you're not that important. You can leave the phone face down. I got 58.3 repeating, yes? So I'll write 58.3 kilometers per hour. Cool. Sapicha, what does it want for the units for part B? What does it want these units to be in? What's the M stand for? Meters? Per? What does the S stand for? Seconds. It wants meters per second. We're going to do a conversion. We're going to do this one so often. We're going to do it carefully right now, see if we can spot a pattern, and then we're going to add a shortcut to our green sheet. So you want your green sheet handy because you're going to write something on it. First of all, I'm going to write down what they gave me, which was 58.3 kilometers, no slanty fraction, per hour. I want to change kilometers to meters, and I want to change hours to seconds. Okay. Evelyn, which one do you want to do first? I don't care, pick. Okay, so where am I going to put kilometers in the next fraction? Yes, and just plain old meters. Kilo is 10 to the 3. Where does the 10 to the 3 go? Where the kilo isn't, in this case on the top. I want to get rid of hours. Where is hours in my first fraction? On the? So it's going to go on the? Does anybody remember how many seconds there are in an hour? I know at least one human does. Ryan. Okay. 1 hour, 3,600. Here's what I notice. Ready? To go from kilometers per hour to meters per second, it's times by 1,000 divided by 3,600. You know what? It's divided by 3.6. So, get your green sheet out, and don't write this down just yet. I'll show you what I'm thinking, and you can write it down how you want. On the front page near the bottom, I'm going to write kilometers per hour. Over here, I'm going to write meters per second, and I'm going to draw an arrow, divide by 3.6. By the way, if I divide by 3.6 to go from kilometers per hour to meters per second, what do you think I'd do to go from meters per second back to kilometers per hour? I think if you write that, something like that, that's probably clear enough that you'll figure out what we're getting at without having to write a big paragraph. And I know from experience about 90% of you will end up memorizing this out of sheer laziness, which is, again, the only reason you should memorize it, but it's on your green sheet. Okay? Yes? Everybody added it? If there's somebody who's away today and they sit next to you, when you see them in the next couple of days, I'll probably, when I see them, hey, we added something to our green sheet, they'll ask you for it, you can give it to them. So, what's the answer? I saw some of you typing already. That was good. You know what? I'm going to use my answer button. Although I wrote 58.3, I'm just going to go divide by answer button 3.6, 16.2 meters per second. Yes? I like example A, I like example A, I like example A. Example A is a nice question. How many of you have ever been at a nice echo place somewhere, a really good one, where you can yell something and there's like a delay and then you completely hear it back and then maybe hear it back again and then maybe even hear it back again? Has anybody had a really spectacular echo? You've missed out. By the way, if you ever do find such a place in the wilderness, cast your maturity aside, be a 6-year-old kid, and have some fun with the echo. There's some neat physics going on there, but it's just kind of cool to hear your voice yelling back at you, yelling back at you, yelling back at you. The speed of sound is 330 meters per second. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears his echo, echo, echo? What's this question asking me to find? So let me pause. In physics, we deal with word problems, but they're not the sucky word problems that you have in math. The ones in math are very contrived, and half the battle is, okay, what do I let X be? Is there a Y? And one of the things I love about physics is it's pretty obvious what they're asking us to find, usually. Jordan, what's this question asking me to find? It's okay. I think that's a distance because I see meters, so I'm going to say I don't think so. Read me the question phrase.
How long will it take before showing?
Okay? I picked this phrase on purpose. Don't feel bad. How long is a vague phrase? Because if I say to you, how long was the movie? I mean time. We all understand that. Nobody says, oh, the movie was 180 meters long. But if I say to you, how long is a football field? Nobody says, oh, the football field is 19 seconds long. You all understand there it means length. I picked how long on purpose, so don't feel bad. Is this how long time or distance? How do you know? Because they gave me a distance. Usually, once I've identified what they're asking me to find, I like to write down I like to write down a question mark next to what they're asking me to find. Why? I've written something down. I feel better. It's no longer blank. And then I like to go through the question looking for numbers and physics words and just listing my data. That 330, what is that? What are the units next to that 330? So what is that? That's a speed. That 420, what is that? How do you know? Meters. I'm looking for an equation that's got a T, a V, and a D in it. There is one. I'm going to go T equals D over V because I like having the thing by itself on the left, like you're used to in math, but I would give you full credit for the other one. Okay. Distance is 420. 330. We're going to finish with this. I've made a mental decision. I'll finish this lesson next week, Wednesday. We'll also be doing a little lab activity. I can get them both done in class. 420 divided by 330. Jordan, did you get what? Now, ready? If you are not following on your calculator, I'm coming at you. And it's obvious when you're not following on your calculator. Dumb is not following on your calculator. We're going to be getting into some really complicated stuff. And every year, there's a kid who has all the wrong answers on their test because they were too stupid. You know what? I'll say it. Too stupid to bother typing into their calculator during the lesson to figure out how their calculator works. Don't be that person. Okay? Lean head up. What'd you get? Everybody get that? For a candy, why is that wrong? Because it is wrong. No, it repeats. Your calculator rounded off because it's stupid. Don't trust your calculator. You are smarter than your calculator. Okay? Why is that wrong? I got here. Nope. Nothing to do with units. Why is that wrong?
Oh.
Do you see it?
7 would round
Nope.
to it? Oh, we wanted to say 6 and 9.
Here's your hint. Think echo, echo, echo. How do echo, 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 echo? Work. What? An echo, the sound has to go there and what?
Back.
That's a bit sneaky, but echoes are cool. I like this question. Candy for you, Davin. So the correct answer is I used my answer button, so I got 2.545. That 4 would become a 5 because there's a 5 or higher next to it, so 2.55 seconds. By the way, this works if you are ever at an echo somewhere, and you want to find out the distance. Time how long it takes for the echo to come back, multiply that by the speed of sound, and you'll know how far, divide by 2, and you'll know how far away the cliff that you're bouncing the sound off is. I'm a nerd, but I think that adds to the experience in nature. There is something kind of cool. Oh, you know what? That cliff is 900 meters away, and I know it, even though I don't know where that cliff is. That's kind of cool. Jordan's not impressed. I will get you at least once. I will get your inner nerd. We're going to pause here. Thank you very much for your patience. I will assign, the reason I'm pausing, I don't like giving homework over a long weekend. So tomorrow we'll start out doing a bit of a study time. We'll write the quest. If you need to go into lunch a little bit tomorrow, because the block order is block G is before lunch, you can. I'm okay with that. You'll get the quest done. Then Friday, you'll come here, but I don't think you need to bring your binders with you, but don't skip out. It is an important, very, very timely assembly, and we'll go to the assembly.